right, ladies and gentlemen, we are back. We have an hour and a half, and then we'll be done for the day. If I don't hit everything, I am going to be putting all of this out on YouTube. I have done multiple practice sessions. You'll notice if you look at those original practice sessions, they are different from what I actually wound up with, because the practice sessions inform me over what I actually want to say and how I want to say it. If you are not in the GitHub yet, please open up the GitHub because I need you to download a file. I'm going to leave the QR code up for a couple seconds, and then we're going to go get the Word document that says Healthcare Data Nodes. I'm going to be giving you 5 minutes to work with your table to come up with how we're going to prompt engineer an ETL. We're going to be combining the data from one data set to a second data set. So the GitHub is CSV datasets to normalize .docx. CSV datasets to normalize. It should look like this. So, what you are going to be doing. The computers, they be hard. So the Word document should look like this. It's got a data set 1, and it's got a data set 2. And what you are going to be doing in the next 5 minutes is trying to write a prompt that's going to do an ETL to normalize dataset 2 to dataset 1. And if you do it the other way around, it's not going to matter. This is just a practice on how are you going to build a good prompt. For those of you who weren't here at the beginning, there are a number of vendors. Here we go. That do offer free LLMs. I highly encourage you to use LLMs to help you test your prompts. That's why I give you the actual data sets rather than just have you, we're going to do some imaginary work of combining 2 different data sets. After about 5 minutes, I'm going to ask a few tables to speak up and say what things that they identified or found. And then I'm going to show you how I do the ETL process and how I do the prompt. So, does anyone still need this slide? It doesn't look like anyone's looking up, so I think we're safe on that. If anyone needs to get help, please let me know. And then let me get back to somewhere in here. Prompt engineering. Remember, when you're working with your table and talk to your table mates, how am I going to do this? You're going to want to specify a role, you're going to want to specify some context, and then you're going to want to give it a specific request as part of the normalization process. Expanding.
Can you hear me? It's hard to hear you.
Hello, can you hear me now? I was realizing I'm going to get a bit confused and I may have to drag my screen back and forth to get this right. Alright, so, 1, if you're using the O1 series of models, think of the model as DeepSeek, it probably just did this for you without you even doing any type of prompt engineering or thinking about the prompt itself. If I just type it in and say, please normalize these 2 data sets, and figure it out, and it does a pretty good job, and it'll rate Python code that does it all. One of the problems, so I ran into a friend, I made a new friend in HEMS, and they were talking about, I keep having all these data sets I need to normalize, and I can't do it, and it's really a challenge. And so I'm like, well, it's just all prompt engineering. It's not hard, and I was trying to talk them through, and I wanted to give them an example. So I generated these 2 data sets, and it kept answering the question rather than building a prompt for me. So, how do I build a prompt? All of this that you've just struggled with for the last 10 minutes. I cheat. There on OpenAI is a good document in the developer section on what it takes to have a good prompt. I go and I copy that in its entirety. I go and I will say something along the lines of, please write a prompt that, according to the best practice principles below, I can't type and screen and go over my shoulder at the same time. Please write a prompt according to the best practices below that will normalize to healthcare data sets. And then I copy and paste. It has forgotten my copy and paste. Oh, no, it didn't. It's Claude. I forgot. I'm challenging myself. My O1 Pro subscription expired, so I'm using all the other models for a few weeks to just get used to it. And so I pasted the prompt engineering in here, it pasted the data set in there, and if I hit play, Claude's going to maybe just try and normalize the data set for me. But here, okay, good, it didn't. I need help normalizing two data sets. Data set 1 has these fields, data set 2 has these fields. Please create a standardized schema. And it gives me the start of a prompt. Make sure I'm providing standardized field name, original field name, data type, standardization. I can go in here and please make sure to use a role or persona. Please give it more context. Please be specific in your request. And it'll build a more enhanced prompt. This gets me 90% of the way there, every single time. I can go read that prompt and go modify the prompt to whatever I need it to be. But I don't spend a lot of time thinking about my prompt engineering anymore because this gets me to be started on the path. It's only if this fails that I'll go actually spend time, energy, effort to build a really robust prompt with all of my knowledge. I encourage you do this type of thing. A lot of it, you can also just cheat. I've got a slide down here, and I tested this prompt extensively. I just locked my screen. I tested this prompt extensively, and I can't do my screen anymore. Hang on. This expanded window thing is beautiful for PowerPoint, so hard to share your screen. All right, I tested this extensively. Where did I stick it? Oh, damn. It must be farther along. Here it is. All right. If you literally don't do anything else, and you're just saying, I need you to act as a large language model prompt engineer, so create a verbose. And verbose is important because otherwise it'll do a very short response. Prompt to do the following, description of the thing you want it to do. Again, I do not want you to do these instructions. I want you to build a large language model prompt, like a prompt engineer that will achieve the task in a single shot. It does a really good job. It does a better job if I copy and paste the actual text of how to do prompt engineering. But, so I wrote this prompt specifically for the book that I spent a year of my life working on that will be published in July on large language models in healthcare through Taylor and Francis. So connect with me on LinkedIn and you'll see when the book gets published. But I tested this extensively and it works very well. And most people can at least remember this much to go tell it to do this. Okay, I gotta go back. So, were there any observations that you made while you were doing this with the hands-on activity that you would like to share for the club? Anything that I didn't cover?
In the chat, ask you to import data set. What do you want to do with it? So actually, you wrote the code, and wrote like the Python code, and brute forced it, rather than doing something.
So if you go look at so I wrote on my large language model newsletter for this guy who's doing the normalization process. And my prompt there is you're going to do the analysis and then you're going to build the pipeline to do this normalization process. What I didn't cover in that article, so if anyone is in the business of ETLing, you'll know this already, but anyone who's not, once you do this ETL process, then you need to go do data checks and validation process checks. And you need to make sure that, one, the mapping passes the sniff test, but usually the mapping passes the sniff test. But when you're having an auto-generated code to do these things, you need to go validate that it actually ported the data from one place to another and do some spot checks along the way. So, with that, if no one has any other comments or questions, I'm going to explain LLM agents in 2 minutes or less. If you've been at HIMSS the last week, you've heard nothing but agents, 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 agents. An LLM agent is a prompt. It's a really exciting prompt. Or not. So, an LLM agent. Agent 1, you're going to go analyze these symptoms. It generates the output. Agent 2, using and running on the exact same LLM, is a brand new prompt that tells it that you are a medical specialist. And it takes the output from Agent 1, has a new prompt telling it what to do with the output from Agent 1, and it does it on Agent 2. It then has its own output, and that output might go to Agent 3, which is a diagnostic evaluator. So I call them graders, other people call them different things. It's an evaluation step which is going and saying, is the output here actually making sense? Is it good enough? So I tend to do everything where I grade on a 10-point scale, and I tend to find that it functions very well to tell it that it's going to be an academic grader for a PhD level course, and it gets really nasty sometimes in its grading capabilities, which is great because I want it to be very specific in how it's graded. And then whatever that grader says, it either says it's scored well enough to go to the next thing, or no, it's not, and it's got these problems, and then you go back to the agent number 1, and you keep doing this round robin. At the core, agents are just different prompts, sometimes running on different models. Often we attach them to tools, but at their core, agents are just prompts, having to do different activities and talk amongst itself. The original agents were literally like there was a software developer agent system that was released like 1.5 years ago, 2 years ago, and it was literally, you're going to act as a CIO, you're going to act as a director, you're going to act as an HR specialist, you're going to act as a developer, and that's all the context of it. It was the world's simplest prompts. I did fun little side projects because I'm a geek, and built better ones, and prompt engineering is a real thing, and it's important. So, you'll also hear the term RAG. I don't deal with RAG a whole lot because I don't think we're going to have RAG very long. RAG seems to be something that until we have infinite context windows, it becomes very important. And after we have infinite context windows, it's going to be less important. RAG is retrieval augmented generation. All it is we're going to take your prompt, we're going to go do a search, usually using some type of search engine-based algorithm that's going to go look through all the documentation that you have within your internal website, all the documentation on the web, is going to bring it all back, put it into the prompt itself, and the prompt instruction is then going to be able to reference all of the active real data going on to do the response generation. So again, it is regular prompt. I want you to tell me everything there is to know about GLP-1s. It's going to go out on the web. It's going to find all the academic articles and all the research papers on GLP-1s. It's going to bring it all back, stick it into the prompt, and it's going to say, you're going to do the following activity. Tell me everything there is to know about GLP-1s. It's going to have all that context in the prompt, and then the response that's actually generated becomes much more specific, much more useful, and that's all RAG is. When we have infinite context, so and with Gemini with 2 million token context windows, we have pretty darn close to infinite context windows for most normal large academic medical centers. You generate a lot of text and a lot of information, but RAG becomes less important because you can just always have that information as part of your tokenization in your context window. And so I don't see it as I see it as a short-term solution that we are slowly engineering our way out of as part of the future. Deep research. So Google, OpenAI released deep research 5 weeks ago, 6 weeks ago, somewhere in that time frame. It is an agentic AI system that goes out on the web and will find lots and lots of information for you about anything that you ask it about. I have asked it about things like, hey, I'm writing fiction books. Does it matter how many reviews that you get when you try and market and advertise a fiction book? Turns out it does. It went and found specific information over, here's, if you have 10 reviews, how many conversions you should expect. Here's 25, 50, 1,000 reviews. That is an area where I have read some, but I am not an expert. And so it was able to give me specific references, specific links, and specific information. I tried it on doing a stock analysis. So I chose an individual stock called Verizon. I've got an individual stock of Verizon, and it did a full stock analysis as if it was the same quality level as any of the full stock analyses that I've ever paid for, because it's just using public information, and it will go out and retrieve in real time the public information. I've used it for lots of biomedical informatics questions. I have specifically published a newsletter in my informatics newsletter where I shared the specific prompt and the specific entirety of its output. And one of the things that I did find that is important for all of you to know is it's very important to specify if you are trying to get high quality results back that you are using PubMed or you're using specific academic journals, because otherwise it will grab anything from the web that it finds, and that can be really questionable. Other people have experienced hallucinations. I've never had it not have a link that's actually real. And I've really never had it use a link that is fake when I have specified you're going to pull this from PubMed or academia. Some of my fiction stuff, it has pulled links that I disagree with what it thinks it said versus what it says, although then I used the Wayback Machine and I was like, oh look, some of the time in the history, the web would send something closer to this. But just something to be aware of. We are entering a time where you can build a decent academic paper that is as well researched as a typical master's degree student in 30 minutes or less. That's really powerful if it is something that, okay, I'm doing some new novel research and I need to get all the references that are similar to this, and maybe I don't have all the references, and you go out and find them. It's not going to, so if I have not convinced you yet by showing you all of this math stuff, that this is not thinking the way people think, that this is a different type of intelligence, I've failed to do my job. This is not artificial general intelligence. It does not know what is going on. When it does deep research, it does not understand what it's returning. It does a bang-up job, and it really, it can fool you so easily. But it fundamentally doesn't understand. It makes very different choices than what a human would make. So if you look at that newsletter where I put the prompt and put the output, it had to do a history of biomedical informatics. It made some weird choices that I don't think anyone who has a history of biomedical informatics would have made the choice. It's not that it's wrong. It's just, it doesn't think like humans. Let's see, strategies for clinical prompts. Make sure you're clearly defining the scope. Maybe we only want to focus on medical interactions. Make sure we're including relevant patient history. The FDA is looking at these, and you're going to have to get FDA approval for a lot of large language model prompts. Sometimes we get away with it in research because we're not trying to do it enterprise-wide or enterprise-grade, but be aware that you need to be careful about your thought process over how you're validating these and how you're protecting patient safety. There are a lot of common prompt engineering mistakes. We often see overloading prompts. So if you give it too much context, too much information, it can break it. It's becoming less of a concern as we're getting larger and larger context windows, but it's still a concern. It still happens. I was chit-chatting with my expert in the front row about the fact that it is easy to over-engineer a prompt, but we have a lot of academic research that is currently being released saying this is how much an LLM can do. And if they have not tested a prompt that is at least 500 words, I don't consider them to have actually proven whether or not an LLM can do this thing. Almost every research paper, when I go look at the prompt that they are testing, it's a paragraph or two at most. When I go up to your posters, I ask, what's your prompt? And last year, I had one person have, here's my written prompt, and it's 12 pages long. And I was so excited. And it was a student. He was in a high school program, and this guy is an LLM expert. But these are the questions that we need to be asking. If you are going to be presenting any information on your LLMs, you need to be willing to expose your prompts. Prompts, there's no intellectual property there. We can achieve the same end with lots of different ways of using the English language. As soon as you show someone the output of an LLM and you tell them that it can be done, there are going to be experts who can look at that and come up with, here's how I did prompt engineering. And yeah, they'll have to test in different ways, but they'll get it. But Napkin AI, I looked at it and I'm like, oh, this is so brilliant! And I thought about it for a few hours, a few minutes, and I was like, this must be how it's done. And then I went and built it and proved to myself that it could be done that way. And I realized I can't build pretty things. And so there's a GitHub repo if you want an LLM. It's open source that does the same kind of header and bullet points, but it's not nearly as good. Question?
I'm just a little curious, what do you consider as a prompt? Like, so, for example, just now the data set that you provided, there was also considered prompt, because like, if that's solved that easily, you easily have a very, very long prompt.
Not sure that I follow your question. So
if I have some instruction and I attach the data set that we ask the LLM to analyze, do you consider the data set, extra context, or even the Python code as part of the prompt?
So it is part of the prompt if you're giving examples. So the prompt here where you are giving it, so the one that we just did, that would be part of the prompt because you're giving it a specific text. For the actual prompt engineering, I would argue that that's not prompt engineering because you're having it take actions against those, but you need it to be part of the thing. The prompt engineering I'm looking at is that what's your role, what's your context, what's the information do you need to be able to do this role context pairing. And so it's just a little different, I would argue. We already did this ethical prompting. So in healthcare, we do need to start thinking about ethical prompting and how easy it is for people to do prompts that are unethical. We need to think about what our de-identification techniques are. We have a lot of LLM vendors out there now saying, oh, we can de-identify all your notes. We just have a prompt that says, de-identify everything in this note. Here are the 18 HIPAA variables, remove any of them that are there, or replace them, or something along those lines. That may or may not actually accomplish your HIPAA de-identification step. And you need to think about that and be aware of that. We have a lot of the same for aggregating and anonymizing, and the re-identification risk is significant. So if you are fine-tuning your models, so fine-tuning, if you remember, is when we go and take new data and tell the LLM we're going to make you output things that are closer to this new data. If you fine-tune on patient notes, that LLM is going to contain information about your patients. It is patient-sensitive data at that point. Never expose that to an API that is anyone outside of your health system and anywhere outside of your EHR for the most part. Do not fine-tune on your patient data without. I just say right now we're probably at a point in history, unless you're a researcher, you shouldn't be fine-tuning on your personal data for your organization because new models are being released too frequently for you to. You just want to constantly be adopting the new models because they just have so much improvement. If you're a researcher, that's a little different, but just something to be aware of. Anytime that we do patient information in these LLMs and it gets trained into the LLM, that information could show back up out in the future. ChatGPT, when it was originally released, had all sorts of individual persons' names, phone numbers, and things like that. And occasionally we'll find something in ChatGPT which is hard-coded to block people's names, and they have to go do things. It gets pretty funny in the LLM space. This is an example where there might be a little bias in this prompt. And I'm sorry, I hate reading slides out loud, but I'm going to do it. Based on the patient's ethnicity and socioeconomic background, determine the most likely diseases they might have. Would be a very generic prompt. A more specific prompt that I very easily could see myself or someone writing is, if a patient is a white male living in a low-income area, determine the most likely diseases he might have. Focus on conditions commonly associated, such as poor nutrition, lack of access to healthcare, and high rates of smoking and substance abuse in low-income white populations. And replace white with whatever other classification you care for. Someone, somewhere in your organization is going to think that this is a good idea. This is going to introduce bias. There's a whole presentation apparently on bias in healthcare AI. But I did promise to talk about bias. So, there are a bunch of different places where this introduces bias. Telling it is white patient introduces a bias. Whether that bias is a good or bad thing can be highly dependent. This is why we wind up building large language model governance committees. And large language model governance committees are very important because they're going to hopefully bring the expertise to the table to be able to start doing some evaluations. Just because I am saying this is a white male living in a low-income area doesn't mean that I am specifically biasing the LLM in a way that is going to be detrimental to the health and wellness of the person involved. If these are low-income areas with low-income people, and we are biasing the LLM to help find additional resources, bring up additional capabilities, that may be something where we write these exact same words in a different context. But be aware, when we give LLM capabilities to the lowest common denominator in IT shops with LLMs, they're going to be running LLMs prompts that could bias in very negative ways, and could bias in positive ways, and there needs to be an oversight of governance. And so we need to push our EHR vendors that every time they introduce a place where an LLM prompt is being used, we can both see it, and we can have some oversight and visibility to it. So, prompts can be good for hypothesis generation. Be aware. It's just throwing things against the wall. So Google made some really big news over solving it for math Olympiads with large language models. What they did was they, in Part, just went and had it generate random things that sounded right, and they went and tested it tens and thousands and thousands and thousands of times until they got the right answer. That's not intelligence like I think of intelligence. That can get the right answer. a lot of what it's doing with all of the bio side, and hey, we've solved a lot of the problems, is it's just throwing up random answers that sound right and testing it, and it keeps going and iterating on it until it gets to something right. That's not a bad thing. It's going to give us a future that is fantastic, where we can have molecules very specifically targeted. But we do need to be aware of its marketing hype to say, hey, look, this is intelligence the way we think of intelligence in the past. So when you're asking for hypothesis generation, be aware the way it's doing it is it's throwing things against the wall that sound somewhat right. It's going to take you as an expert filtering it and being aware of it. And so that was my prompt engineering takeaways. I have a lot to say about ethical considerations. At the end of the day, when you're doing large language models and you have to think through how we get to the bias in large language models, it starts with the data. Large language models are trained on data. And so when you're thinking about bias mitigation, right here at the start, data cleaning is going to impact your, so think of this as like a tail, where the beginning framework can drastically change the final output. So if you're not looking at your data cleaning process, if you're not measuring what data you're going to be training your LLM on, you are going to be introducing bias. Maybe good, maybe bad, we don't know, we haven't measured it. If you're not making sure as you're labeling it, you're helping do some labeling. Again, it's just we don't know what we're doing, we're just going to blindly label this. That can cause some really amazing bias. And I'm going to show you a screenshot of a bias, because I think it's fun. I write fiction books. All I wanted was I wrote a fantasy novel on a blacksmith with magic, swords, dragons, yada yada yada. It was supposed to be 17. I didn't have an image in my mind, whether it was white, black, nothing. I just wanted a young man. I go in, and I start having it generate, and I get romance novel. Blacksmith romance novel. I start generating, and I can't generate anything other than a white guy. That's a bias that is really darn obvious. Now, maybe this is the type of cover that I should want. I'm obstinate enough that I don't want this type of cover. I want something that is like a normal human, not just the perfect romance novelist. And so, a lot of bias in large language models, perceptrons, image generation, voice generation, whisper AI, it's not this obvious. This is only obvious because I'm showing you 20 images right next to each other. If you were just generating them one after another and doing little minor modifications, it may not be nearly as obvious. And it was never good at generating anything other than, if I specified black, if I specified white, it would do that. But racially ambiguous, not so much. Tan, not so much. It really, really, like the romance covers for this type of prompt. And I tried lots of different prompt engineering. So, when we're automating, and we do a lot of automation for our LLM data cleaning, we have to identify manual detail tasks. We have to introduce LLM prompts. Then we still have to go through and analyze whatever data the LLM prompts actually generate and do. And then we can create the final ETL processes. Make sure that no matter what you're doing with the data, you are measuring both the inputs and the outputs for bias. We have specific techniques available. It's too far in the weeds for this presentation. I've written a lot about it, lots of people have written a lot about it. Just be very aware. And then I have a specific hands-on tutorial that I want you to do. I want you to go ask the LLM to generate a synthetic data set for you. I put some text here. You can choose whatever text you want. But my text was, please generate a table of the typical ambulatory clinic patient load. I want the table to have 100 rows. I want demographics, name, age, gender, race, height, weight, city, state, employer. I'll give you 5 minutes to get a table generated of some sort. I encourage you to also, maybe not use the word typical, maybe use Pittsburgh or wherever you're from. Maybe make it ambulatory, maybe make it inpatient. Try different things that you want. All right, I'm going to assume that you've had enough time. So I had Claude generate a table. Also had GC. I had a few different ones generated for me. Go and say, please generate a count of each relevant column of the number in each category bucket, age, and weight. So in Claude's example, they use 33% white, 26% Asian, 21% black, 20% Hispanic as a typical clinical load in America. Age distribution, 25% in their 60s, 30 to 39 is 21%. Only 5% are 70 or older. Weight distribution, 69% fall between 120 and 199 pounds. So, this is not a typical data set. This is a typical data set for people like me who go and are testing data sets, and you want an example of every type. When I said typical to it, it didn't take it that, hey, I need to go look at the demographics of America. If I go tell it based on the demographics of Indianapolis, it still fails. It gives me one of every type, whatever categorization it uses. This is another type of bias, and it's not an obvious type of bias unless you've seen it. And so we have a lot of different biases at a lot of different levels within our data. And I just wanted to call out to you that you can't trust these things to be unbiased. You have to make the assumption that this is an adversarial relationship where there is a bias being introduced, and you are looking to mitigate the bias as much as humanly possible. Are there any questions about that? I'm going to get my slides back. So we use a lot of different techniques when we're training these elements. We generate synthetic data for things that we have underrepresented. We do oversampling. We do post-processing. But at the end of the day, it's all about our monitoring and feedback loops. ChatGPT solves most of its problems with generating inappropriate adult content by secondary steps. It fine-tunes saying, no, I won't generate this thing. But then the secondary steps where it validates and says, hey, it is this thing, and don't show this to the end user. Sometimes it is asked to do it, it generates it, and then half an hour later it disappears because the processing is caught up. That you're not supposed to generate that type of content on ChatGPT. I do not, but I am part of many groups where this is a problem where they are constantly trying to hack ChatGPT and the other models. Apparently Grok lets you do a whole lot of things that is surprising and not in a professional setting. So, there were lots of other things that we can consider, but I'm going to keep us moving. Just remember we do have methods of detecting bias, and we should be applying those. If you aren't an expert in it, someone is. And go look for those resources. Denny, who comes to a lot of the AMIA stuff, has spent a lot of this in large language models and AI and ML. I met him first at Ohio State. He's the green-haired tall wonder, usually in a cult of some sort of skirt. And he lives over in England? Sheffield. Anyway, fantastic person to bounce ideas off of if we try to figure out have I done enough against the bias inherent. So, all of this is to argue we need governance committees in our hospitals. A lot of organizations have implemented these governance committees over the last year. If you are in research and you do not have representation from research on those committees, get on those committees. For those of you who are not deeply ingrained into the health IT space, there were a number of hacks in the past year through third parties and third parties who are using large language models that have made people nervous. And so there's a lot more governance oversight now on implementing anything with LLMs in your hospitals. And you need to be aware of it. And there are legitimate reasons why we have these additional governance committees. Many of those governance committees may disband over future years, but we're probably 5 to 10 years away from them disbanding because we've got enough ubiquitous knowledge. Right now it's in the hands of a few people in any health system, and that's just the way it's going to be for a while. There are a lot of situations that you introduce legal liability when you're trying to use LLMs, and we do need to think about those things. The high-risk scenarios are any time that we're trying to directly do something to a patient. Medium risk scenarios are when we're making recommendations for physicians, but we're still making them work within their licensure and say, yes, we're going to do that thing that we're recommending. I don't like it so much because we know through human evaluation and testing that any time that we serve up a recommendation for someone, people are going to trust it more than they should. People are using Toyotas and attaching fishing lure weights to the steering wheel so they don't have to touch the Toyota steering wheel, and it'll just keep them on the road. That's not even a Tesla. They've been doing the same for Tesla for a long time. People trust it, and if you actually dig into the weeds, it might not be a smart idea to trust these tools as much as we do trust it. As humans, if we've seen it work 10 times, we assume that it's going to keep working every time. And LLMs just don't work quite the same way. Some states are starting to implement requirements for robust disclaimers. So California added some laws to the land where if you are automatically generating replies to patient notes with an LLM, which tends to be a really good use case, you have to disclose that an LLM generated it. Turns out though, if you have a human in the loop, generate the response and then send it to a physician to click send, and they've reviewed it, that does not count against California's where we have to disclose it. I don't mind that. Honestly, I'm really excited. I think that it can solve a lot of problems and can help physicians connect with their patient population better with minimal additional burden on the clinician. This is just a really good use case for an LLM. And so, as we think about these things, we just have to think through how are we mitigating risks? We have responsibilities in healthcare, and especially when we're implementing it into clinical use. We need to not do it blindly. We need to have some concept of where are my implications, where are my risks, and how am I going to be addressing those? And as you're proposing projects or thinking about projects, you should be doing the exercise of what risks am I introducing. It's the same as the IRB. Literally, it should be the same as a good IRB process, where you're thinking through what are the pros and cons, risk rewards for every step of this process. We have a lot of different abilities to overcome data quality issues. Just because this is Amy and I thought it should be mentioned, we do have the ability, and we should use the ability to leverage terminology standards. LLMs have taken over a lot of our historical NLP techniques. It is very easy for me to go to an LLM and say, pull out the height and the weight, put it into a JSON object, and it will pull out the height and the weight, and it'll pull it into a JSON object very easily. I can ask it for spina perfecta and specific details around that disease state, and it'll do it from a note very, very easily with no custom training, and I don't have to spend 10 hours trying to build a custom NLP solution for it. It's amazing, it's fantastic, it's transformative. It's just a different solution possibility than what we've had in the past. What works best is when we pair what we've had in the past with these new techniques to move it forward. And then just keep in mind that you want to do some type of continuous iteration to achieve the best type of performance. So you don't want to just train it on ICD-10 or SNOMED or OINC one time. You want to keep going and updating the training. Keep looking at your prompts so that it's referencing the latest and the greatest to just achieve that robust performance. Some of you may be asking the question, at least I would ask the question, if I'm going to want to use these tools, why wouldn't I de-identify everything before I do fine-tuning? And the reason for that is over-de-identification tends to reduce the model accuracy and ability to predict what you want. So there are many use cases in healthcare specifically. You want to train it on real patient data with real patient information, but you need to be aware of you're going to reduce the accuracy if you're trying to de-identify. And you had a question.
Well, I had a comment. So for those who are using the LLMs for data extraction, keep in mind that they're non-deterministic in some levels. So the fact that it worked on 10 examples doesn't mean that it will work on all of the examples. And even though we've documented this multiple times, where you may prompt it and say, pull out the height and weight from this particular data set, you pass it over a bunch of them, and all of a sudden there are data values that are not identical. It is unlike these other repeatable processes that are.
All right, so I'm going to show you this, and then we're going to do another 10-minute hands-on. So I was bored the other day. I get bored. I start thinking about things, and I started asking myself the question of, why don't we have good synthetic clinical notes out there in the world? And so I started saying, well, we have LLMs. Surely we can build good synthetic clinical notes with LLMs. We can. And so I built an agent-based system. Again, agents, just lots of prompts thrown together. It's a workflow. And so for my agent system, I said, I'm going to build synthetic clinical notes. I want to create a physician table. I want a physician table that gives me information about the physician. This physician's from Ireland. This physician's from New York. This physician's from California. This physician is a highly detailed person. They never make typing mistakes. This person is very fast. They frequently make typing mistakes. This person, and I gave it a list of different things that I was interested in. For, hey, we're going to be building notes. Then I assumed that I was using an OMOP database. The OMOP database already has lots of patients, lots of specific information about specific encounters. And then I created, or I had the LLM create a SQL table to do the notes, grab the notes, generate the clinical notes, and then so it would take the clinical note, take the physician who was writing the clinical note, take the specific information out of OMOP, and write the clinical note based on that encounter, creating fictition about that patient's history, fictition about what's going on with the patient outside of that specific clinical encounter, making sure that we're respecting all the discrete details, but having a brand new clinical note. and then I'd grade and iterate on that note. And that grading process would say, do I have enough specificity? Do I have enough information? Is anything in this new note that has been generated directly conflicting with all the previous notes that have been conflicted? And then I'd save that note to JSON. And what I was testing was not whether this workflow would work, because I knew it would work just after I thought through it. I was testing if I could have an LLM generate in a single shot the code base to do all of this. And I got about 90% of the way there. The actual prompts that I used. And I'm going to pull it up so that I can show you. I had it up earlier, but I managed to delete the tab, which is always a dangerous thing. Alright. Here we go. I have an exciting idea. I gave it a rough workflow, and then I cheated because I've done lots of agent Python code, and I pasted in 2,000 lines of Python code, so it knew what an agent-based Python code would be, and it would be building it the same way that I write my Python code. I tested it with and without it. It got about 90% of the way there when it had my code to base it off of. And so what I want us to do is, you can make your choice. Go back to the GitHub. And I put these all as docx. Hang on. Let me pull up the docx on my book. I think it's the agentic questions. All right. This one. So I gave 10 different options. Choose one at your table. I don't know which one. I was not expecting this many tables. I was expecting to break it all to 10 different groups, such and such. What I want you to do is just take 10 minutes and start talking through what would it take to build this custom workflow. And these are all different types of workflows that we might see within healthcare. And if you wanted to do, hey, we're going to build synthetic clinical notes and we're going to make it really good, that would be excellent. I was talking to Sean Brannis, who does patient linkages, and he was like, well, we don't have a good synthetic patient linkage data set. This is the same type of workflow that would be good for building synthetic data linkages. So go find the GitHub and the agentic questions and take a few minutes with your table and start waving me over if you need ideas or thoughts. Is that clear as mud? Mostly just start thinking through what would you need to do, how would you start defining workflows, stretch your muscles for what type of prompts would we need. It's a lot of diagramming.
Yeah, I think so. Yeah. I think it is. You have to be an expert. Yes, yes, I think there's been some rhythm.
One minute left. Alrighty, I'm sorry to interrupt, but we've only got 15 minutes left for our session, if I remember right. Unless anyone wants to go in case when they kick me out. We all might want lunch or something. So, I had a fun question, and let me just minimize these and get back to the PowerPoint. Why is it not showing? Yeah. Some days PowerPoint and I do not get along well. Where did we go? There we go. So, when is fine-tuning important and when is prompt engineering important? Fine-tuning lets us change the underlying weights and models, so the underlying map. And so the example I used was we might train it on Moink, but Moink is continually getting updates. And we might train it on the Moink information so that we don't need to include all of Moink in our prompt, but we might need to include all of the changes that have been made to Moink in the past 60 or 90 days since we last did fine-tuning. Overall, this is probably not something that you need to deal with and think about all that much and all that often with where we stand today. In 5 years, probably, most of the large language model computing will be being done locally rather than on cloud providers. Cloud providers are kind of expensive. Local models are getting better and better and better to the point where cloud vendors are going to barely be making anything. They're already running into that problem. OpenAI, when DeepSeek got released, had to drastically cut costs. And so it's becoming a losing game to just be a pure vendor on these things. I did want to do a live demo that will hopefully work. This is my home PC. And let me scroll this a little bit. So I run a tool called LM Studio, which allows me to download any model that is on Hugging Face, which is where a bunch of open source LLMs are served, and I can run it locally. And because I tried to run that business in 2021 for all of this, I had bought a 3090 and a 3080, which I was serving up stuff at home locally, because at the time I would have spent every month the same amount of money that I would have spent on a single GPU. I was like, I can deal with this, so I still have some relatively nice home hardware. The machine's probably a $3,000 machine these days. If I had infinite money, I'd have a $10,000 machine with two 5090s these days. Let's see, my magnifier went away. Fascinating. So I downloaded the brand new QWQ model. I believe Alibaba made it. And if I click send, what it does is I asked it to tell me a short story. It now has thinking. So this is specifically, it's trained on a chain of thought. And what it does is it goes and it just starts writing all the different things. And you can see here my local machine, which is relatively nicely resourced, winds up generating about 14 tokens a second. What was amazing to me after I downloaded this 3 days, well, it was released 3 or 4 days ago, and I downloaded it a couple days ago when I got back from Homes. This is the first time that I've ever felt like the capabilities that I can run on my home hardware are equivalent to GPT-4o, and getting closer and closer to O1. And so all of this is just it thinking. This is somewhat different than the O1 series by ChatGPT. They actually do some smarter things where they're not actually generating words to help with the tokenization process, and its thinking process is being done with math. And it gets complicated to explain. QWQ solves it by thinking out loud, and it has generated thousands and thousands of tokens for me, which has been kind of nice. And you can see here, it just keeps going. I don't know if I'm going to break this or not, but let's, so I knew I wanted to record this, and I have a Nikon, whatever. And I had no idea how much memory time that I'd get out of the recording, and then I said, okay, I need to calculate this real quick for 128 gigabytes. So I said C62, which is the type of 128 gigabytes of memory. It had to think for 4 minutes and 21 seconds to come out with this output, but it came out with the correct output. It told me exactly how long, how many megabytes per second. It told me how to do the calculations, the practical limitations, and the total recording time. All on my home machine. Didn't have to go access anything outside my house. And so for me, that is incredibly impressive. I did talk to a few people who are using hardware at their local institutions. The other thing to be aware of, we can now build back mini towers for about $20,000, which can run the very largest large language models that are open source, so the long 405Bs. So if your server teams are not providing H100s, 80 gigabytes of RAM machines, because they're, $40,000. There are things that we can now reach at the research level that can generate the same quality output as some of the best models that you can purchase. Again, I have not found anything that comes close to touching O1 Pro for its versatility and capability that is purchasable. I am sure in-house Meta and others are running better models than that. But I did want to show that from a live demo standpoint, and you can see it just keeps going. And it follows, if I tell it to generate 4,000 words of text, it generates 4,000 words of text, which I was very impressed for a local machine. And it did not do that in the past. You had to do quite a bit more. For LM Studio, the other thing to be aware of is, and I have to eject this model to be able to run. So there's a developer area where you can go select all your different models. And then it's serving out as an API. So if you are doing that Python code, for example, once it has examples. Again, typing is hard when you're doing it over your shoulder and in front of a giant crowd. So I wrote a random GitHub repo with an agentic AI that if anyone's a Python coder and is kind of quasi-interested, you can go find it. This was right after it was released, and no one had any chain of thought things available. And so to do good chain of thought, you need a lot of examples. And so I wrote a quick and dirty example of here's an agentic system where it's doing grading and it's generating into a JSON object lots of examples for training data. Doing a lot of using it. There were a bunch of people trying to do those types of things at the time, and I just was throwing out faster. I'm pretty sure I didn't select Quinn. I selected GPT-2 because I was going to show everyone that rather than doing Google Colab, which is a little slow. And we didn't wind up getting to that portion. But let me minimize this. Get back to GitHub for a second. So GitHub, if you drop down to Jeremy Harper, repositories, very punny training data. If you're just looking for a, I do a lot of dad jokes. I apologize. If you're just looking for a quick and dirty Python example of an agentic system that has a grader as part of it, this is a quick and dirty example. A lot of this was me doing the napkin AI and proving to myself that it worked. And these are the visualizations that I could build. As you can see, napkin AI blows it out of the water. Because visualizations are hard. Python and ChatGPT does not build visualizations well. I was very sad to find this out. Although I found out about sprites recently with gaming engines, and I might be able to get better visualizations by using sprites. I am eclectic and I am a geek, and I apologize for everyone whose eyes are glazing over at this point. We only have 7 minutes, and I'm trying to blitz through the last remainder. I believe I said this, but if I didn't, I have been recording all of my practice sessions and putting them out on YouTube. If there's anything that you have questions on, I probably already answered it on YouTube. I made a channel called Jeremy Learns. If you download the 15-minute video that Amy limited me to for this, I was going to pre-practice around the whole 3 hours. The handle for the YouTube channel is right over my chest in the banner because I felt really bad that people would be. I wanted people to be able to actually see and learn all of this stuff. So, let me get back to slides. Those slides. Excellent. I'm mildly assuming that we've been answering questions that we've gone along and no one has any questions, but if you do, please shout them out. I gave you some additional, hey look, we've got prompts that we can do with summarizing vital signs, planning for next shifts, medical regimes, vital sign warnings. Lots of vendors are starting to try and find ways to improve speed and capability for systems. Future LLMs. I think LLMs are nearing their peak capability. I think we're going to have people like me who are very excited for the changes and the modifications. I think that if you get O1 Pro, and it takes 15 minutes for it to generate the equivalent text, it's going to generate it in 30 seconds at some point in the next 5 years. I don't think that my mother is going to be excited by any of the changes that LLMs provide to the world over the next 5 years. I don't see us on a path to true AGI. I do see us on a path where we are going to be able to facilitate and improve our capabilities, and that if you don't learn how to use LLMs to effect, you're going to be left behind because your coworkers are going to learn it and they're going to do it better. You probably just got dramatically better by learning. You can prompt it to just be a prompt engineer and build a better prompt. And bootstrapping your way up is awesome, and maybe I'm wrong, and maybe we'll have AGI by bootstrapping our way up with synthetic data sets. No one will be happier than me if we get there. We're going to have a lot more regulatory framework. Hans was talking through a lot of different ideas around regulatory framework. The fact that none of the government employees showed up made it kind of interesting, because I think we focused on it a little less than we typically do. And we're going to see more and more integration of vision models, speech and language models into the LLMs. Since it's all working off of a lot of the same core technology, it's not that hard to put it together. I saw someone doing an interesting project on OCR PDFs yesterday with LLMs, and we found lots of ways that we can apply the same technology. But it is a technology, it's not a magic bullet. Again, I would be very happy to volunteer to upload my brain into the cloud and run myself as a super intelligence. I just don't think that we are on the path to do that, in my understanding of the map that we have today. I am happy to be wrong. I'm really happy to be wrong. But you're going to hear a lot of people, OpenAI, saying that we have AGI and that we should completely trust it. Don't trust them, don't believe them, you're all into marketing. I'm not into marketing. There's some post-tutorial resources on the PDFs. Again, those got stuck up on the GitHub. I do recommend that you join any of the working groups on AI. I may or may not be an active member. The open source working groups are good. There are lots of dedicated YouTube channels that can help get you tutorials on all of this. If you have questions, I am happy to give them. Answers, I'm Jeremy Harper. I am a full-time consultant, so if you have anyone who needs help, I'm frequently working as a fractional chief research information officer. And like I said, connect with me on LinkedIn. I do a lot of random articles on there. I have a dedicated large language models newsletter, along with the informatics newsletter. I'm a geek. Thank you all for coming. I really appreciate it. There are a lot more people here than I ever expected.